For countless generations, humanity has looked up to see the vastness of the night sky, filled with curiosity about the universe's many unsolved mysteries. In the 21st century, scientists introduced the Big Bang theory, which attempted to explain the origin, evolution, and expansion of the cosmos. However, despite its widespread acceptance, this theory still struggles to answer some of the most fundamental questions about the universe. New and recent discoveries have introduced even more intricate aspects to these cosmic riddles. For example, in 2023, NASA's James Webb Space Telescope made a groundbreaking observation. It detected celestial bodies that appeared to be older than the entire universe. This revelation has left experts amazed and has sparked a discussion about whether it's possible for stars to exist for a period exceeding the universe's estimated age. James Webb's latest discovery, the age of the universe paradox, challenges our current understanding of cosmic events. Does this anomaly imply the need for a completely new model of the universe? These questions, and many others, will be explored in this video. If you wish to stay updated on the latest cosmic developments, don't forget to subscribe, like the video, and activate the notification bell. Around 200 light-years from Earth, in the constellation of AI, lies a star known as HD 14283. What specifically distinguishes this star as intriguing is its incredibly high velocity, moving at 483 km/s, which provides valuable insights into its tumultuous history. Around 1 billion years ago, during a period when it was still forming in our Milky Way, it collided with a dwarf galaxy that was home to this particular star. However, the most astonishing feature of HD 14283 isn't its speed, but its age. This star is one of the oldest celestial bodies ever observed, earning the nickname Methuselah in reference to the biblical figure who, according to legend, lived for 969 years. Initially, estimates suggested that its age was shockingly old, 16 billion years. But newer calculations have adjusted that number to 14.46 billion years, with a margin of error of about 800 million years. This discrepancy creates a significant puzzle when compared to the current estimate of the universe's age, around 13.8 billion years, as determined through observations of the cosmic microwave background. This raises the pressing question: how could a star be older than the universe itself? Such a scenario seems impossible based on our current understanding. This paradox has led scientists to reevaluate the precision of our methods for dating both stars and the universe, prompting further examinations of these astronomical mysteries. 2. Better understand this issue, it's essential to recognize the challenges involved in calculating the age of celestial bodies. Stars like our Sun maintain relatively stable temperatures and sizes over billions of years, making their age difficult to determine with precision. Astronomers analyze subtle changes in a star's brightness and color over time, then compare these findings to theoretical models that predict stellar life cycles. An important indicator in determining a star's age is its rotation speed. Just as a spinning wheel slows down due to friction, stars gradually lose rotational speed. By comparing the rotation rates of stars of various ages, astronomers have developed mathematical formulas that allow them to determine a star's age using a method called gyrochronology. Methuselah, the star in question, is indeed ancient. Based on current estimates, it is the oldest known star in the universe. Rather than pondering if it could be more than 2 billion years older than its surroundings, we can approach this from a different angle. Could it be that the universe is not as young as we once thought? Understanding the vastness of 13.8 billion years is no simple task. If we were to condense the history of the universe into a cosmic calendar, where the Big Bang marks the striking of the New Year's bell, Earth would only emerge toward the very end of December 31st, while human history would only span the final minutes of the year. Astronomers calculate the universe's age by studying light from the formation of distant stars, hundreds of millions of years after the Big Bang, while the universe continued to expand, creating the phenomenon known as redshift. By looking at both the observable distance and the growth of the universe, the current estimate for the universe's age is 13.8 billion years. However, new research from the University of Ottawa has proposed an intriguing theory that states the universe may actually be much older, approximately 26.7 billion years. Professor Rajendra Gupta, a physicist from the university, has put forward a theory that combines Swiss astronomer Fritz Zwicky's 1929 ideas with new concepts in physics. His theory suggests that protons lose energy over vast distances and time, a concept that contradicts current data about redshift. Gupta proposes that by allowing this theory to coexist with the universe's expansion, we could reinterpret redshift as a hybrid phenomenon, not solely attributed to expansion. This reinterpretation could lead to a new estimate for the age of the universe, potentially offering answers to persistent cosmological questions, some of which have recently arisen in the wake of NASA's findings. Gupta's work builds upon the tired light theory and the concept of evolutionary interaction constants, originally proposed by theoretical physicist Paul Dirac, suggesting that certain cosmic interactions may have evolved over time. It's important to note that our understanding of the universe's age has evolved over the years. For instance, in the 1920s, Edwin Hubble proposed that the universe was only about 2 billion years old, but more recent observations dramatically increased this estimate, eventually reaching the current consensus of 13.8 billion years. Regardless of whether we consider human history as a mere 10 seconds, or even 5, on the grand scale of cosmic time, it is clear that the universe is extraordinarily ancient. Its continual expansion forces us to reconsider preconceived notions regarding its age. At the same time, there are new and intriguing findings regarding our own Milky Way galaxy. Recent measurements indicate that stars in the Milky Way's outermost regions move at a much slower pace than their counterparts in other galaxies. Several possible explanations for this phenomenon have emerged. One suggestion is that there may be exceptionally little dark matter in our galaxy, an invisible substance that plays a crucial role in the gravitational forces of cosmic bodies. Another possibility is that our understanding of dark matter and how it is spread throughout the universe might be fundamentally incorrect. This dilemma stems from data collected by the European Space Agency's Gaia satellite, which has mapped the positions of nearly 2 billion stars. These observations in the Milky Way have caused astronomers to reevaluate their stellar behavior models, particularly in the galaxy's outer regions. The speed at which stars travel is an essential factor in calculating a galaxy's mass, as the gravitational forces on stars depend on the total mass of the galaxy. A recent study based on data from the Gaia satellite suggests that our galaxy's mass, including gas, stars, and dark matter, may be around 200,000 billion times the mass of our Sun, which is 5 times lower than previous estimates. This reduction in mass could be due to the unexpected decrease in visible material in the Milky Way, possibly indicating less dark matter than once believed. However, calculating a galaxy's mass is notoriously complex. There may be uncertainties in the data from the Gaia satellite, or in the analysis methods used. As brand new data becomes available, we will continue to monitor these developments closely. In the coming years, advancements in technology and new space missions will likely shed more light on these pressing mysteries of the universe. The James Webb Space Telescope, with its unrivaled capabilities, is set to continue pushing the boundaries of our understanding of the cosmos. It's not just the age of stars, or the universe itself that we are trying to understand, but also the intricate dynamics of galaxies, dark matter, cosmic formation, and the forces that shape matter. The universe's expansion remains a central focus of astronomical research. But as we gather more data, we might discover that our previous hypotheses were incomplete, or even incorrect. One of the key questions we must ask is whether the laws of physics, as we understand them, apply consistently across all scales and times. Could there be unknown forces or phenomena that affect how galaxies move and how stars age? As our tools for observation become more refined, we may discover new aspects of the cosmos that challenge even the most well-established theories. We are becoming more and more aware that our understanding of dark matter, dark energy, and the fundamental forces may be far from complete. From the beginning to the end, Each new discovery, from distant galaxies to stellar remnants, provides intriguing clues about how the universe works. But each discovery also opens up more questions, pushing the boundaries of what we know. The idea that stars could predate the universe, or that the universe might be older than current models suggest, prompts us to reconsider our entire approach to cosmology. It could emphasize the need for fresh physics models, and perhaps even entirely new ways of looking at space-time itself. It also raises profound philosophical concerns regarding the nature of existence and our place in the vast expanse of the cosmos. If these findings are confirmed, they would not only reshape our understanding of cosmology, but also profoundly alter how we view the very fabric of reality. As the debate over the true age of the universe continues, it's clear that we are at the precipice of a new era in astronomical discovery. In the coming decades, we may find solutions to questions that have puzzled humanity for millennia. Whether it's the possibility of older stars or the deeper mysteries of dark matter and dark energy, the universe still holds many secrets waiting to be unraveled. The path forward is one of exploration, hypothesis, and continuous refinement of our understanding of the cosmos. So while the answers may not be clear yet, the excitement of discovery is only just beginning. Stay tuned for more updates on these groundbreaking studies and theories. Keep your interest alive, and who knows what new frontiers of information we might come across later. If you want to stay informed about the most recent developments in astronomy and space exploration, make sure to subscribe to our channel, hit the like button, and turn on the notification bell so you don't miss any future updates. As we venture deeper into the study of the cosmos, the future holds the promise of revolutionary discoveries. The James Webb Space Telescope, with its upcoming advanced imaging capabilities, is set to play a key role in deciphering the mysteries of the universe. Already, it has begun to provide stunning new information about distant galaxies, exoplanets, and other celestial phenomena. But this is just the beginning. As Webb continues to explore the depths of space, it may find information that challenges our very understanding of the fundamental processes of the cosmos. One of the most exciting aspects of this ongoing research is the search for planets that might support life. With each new discovery, the number of potentially habitable exoplanets grows, and with it, the potential for finding extraterrestrial life. The future looks brighter than ever before. While these discoveries don't provide definitive proof of life beyond Earth, they open the door to the possibility that life may exist elsewhere in the universe. The discovery of microorganisms, or even complex life, on another planet would have significant repercussions for science and philosophy, reshaping our views on biology, evolution, and our place in the cosmos. Moreover, as we continue to investigate the enigmatic forces of dark matter and dark energy, our current models of physics are likely to be tested and improved. These difficult-to-detect substances constitute the majority of the universe's mass and energy content, but we still know very little about their properties or how they influence the structure of the cosmos. Some of the most significant mysteries in modern physics involve understanding the true nature of dark matter and dark energy and how they affect the expansion of the universe. If researchers can unlock these secrets, it could lead to groundbreaking insights into the fundamental nature of reality itself. Another area of focus is the ongoing examination of the behavior of galaxies and their movements. The discovery that stars in the outer reaches of our own Milky Way galaxy are moving more slowly than expected has prompted astronomers to reconsider their models of galactic dynamics. This observation could suggest that our galaxy, and possibly others, might not contain as much dark matter as previously thought. If dark matter is not as abundant as we once believed, it could have profound implications for our understanding of gravity and the overall structure of the universe. This is a perfect example of how new data can force us to revise our theories and assumptions, sometimes in ways that challenge even our most fundamental ideas about the cosmos. Similarly, the discovery that galaxies may evolve in ways we have not yet fully understood highlights the need for a more nuanced approach to cosmology. Could the universe be much older than we think? Are there elements of its history that we have yet to comprehend? These are the types of questions scientists will continue to explore in the coming years, as they collect more information from both existing and upcoming space missions. As these mysteries unfold, it's clear that our current models of the universe are not the final word. There is so much more to find out, and the more we know, the more we realize how much we don't know. This wonder and the ongoing pursuit of knowledge are what drive scientific exploration and discovery.